Hi you guys, happy Friday. I hope you guys have had a good week and have been able to figure everything out. I know it's been crazy. I am ready to do our science experiment. So you guys yesterday did an activity with friction. So you watched that cute video all about friction. I thought it was so funny, that part that talked about how if it were for friction, we'd all be slipping and sliding everywhere. And that was just really funny to imagine everybody sliding all over the place because there's no friction. But luckily we have friction, and our shoe and our ground keep us in place. So then after you watched the video, you read that article, and then you did the discover and explore. So you picked 3 objects from around your house and a book. So I grabbed our Journeys book, and my 3 objects, I chose my shamrock necklace from St. Patrick's Day, and a cutie, and a Hershey's Kiss. So that's for my first investigation. So in my science binder, I would have written down my 3 objects, and then in the middle column, I would have predicted the order of how they fell. So which one would fall first. And I'm looking at these items and I'm thinking, okay, the necklace is really shiny, so I think that's gonna make it really slick. So I'm guessing that this is gonna fall first. And let's see, well, the Hershey's Kiss has a flat bottom and it's kind of, metallic, so maybe that would make it slide fast. But I don't know, because the orange, the cutie, it could roll off. It's like a circle, it's a sphere, it could roll off. So maybe that would do it. I don't know. So I would write down, okay, I'm thinking the shamrock necklace 1, I'm thinking the Hershey's Kiss 2, and then the last to fall would be the cutie. So then I would just lift up the book and watch very carefully. And so yeah, the shamrock necklace fell first, then it was the Hershey's Kiss, and then the cutie was the last to fall. So I'm thinking, I wonder why the cutie was the last to fall. Maybe there's more friction because of like the skin, the texture, the ridges. So then I would do this 3 more times, doing 4 investigations with 3 different objects every time. So we're starting to notice a pattern with these items and their characteristics. Okay, so that was the investigations. So now today we are doing the challenge. How slow can you go? So we have a ramp. It took me a while to find something that I could use as a ramp, but I found this random box, so that was perfect. And so what makes this challenging is that we can't change the height of the ramp. So this is the height. We have to keep the ramp as it is, but we want to make our can of food or whatever it is go slow down the ramp, and to prevent it from traveling very far. So to start, it says brainstorm some ideas here of how to slow down the can. So I can't change the height, so I can't like make it flat, but I could, put a blanket on the ramp, or and that would create more friction. I could glue cotton balls all over the can to create more friction. I wouldn't do something like pour oil or soap down the ramp because that would make it go faster, and I don't want that. So those are some brainstorming ideas. Now we're going to investigate. So for my first idea, before I even begin, I am going to do what's called our control. So whenever we do science experiments, we want to have a control that's kind of our baseline. So nothing has been changed to anything about the experiment, so we know like where we're starting. So nothing's changed to the ramp, nothing's changed to my can, I'm just gonna see where we're starting. Okay, look out, Juno. Okay. Okay. So now I'm going to use my pen because I still don't have a ruler, and I'm going to measure how far that can rolled. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 pens. That's my control. I'm not going to write that down anywhere on that chart. That's just for me to know that that's the length that I'm trying to beat. So 9 pens. I just kind of wrote that on the side. So now my first idea is to glue cotton balls all over the can of soup. So I would write down in that paper what says, what did you change? I glued cotton balls all over the can. That's my first idea. So then I would do 3 different trials and find the average. So again, I'm not changing the height, I'm just letting it go. Good. So I'm gonna measure 1, 2, 3, 4, 5, 6, 7. Okay, so I'll write that down, 7 pens. That was for trial 1. Trial 2. 1, 2, 3, 4, 5, 6, 7, 8. 7.5, about 8. I'll say 8. Okay, last trial before I find the average. Okay, so they're all kind of going the same. 1, 2, 3, 4, 5, 6, 7. Okay, so my average is about 7. I would add up all those numbers and divide by 3 to find the average. Then I'll go to my bar graph, and my first idea, I'm going to draw how far it went. So the average was 7, and so I'll go 1, 2, 3, 4, 5, 6, 7 up the x-axis. The x goes up, or sorry, the y-axis goes up and down. The x-axis goes across. So on the y-axis, like it says, I'll go 1, 2, 3, 4, 5, 6, 7, and then I'll do a little rectangle colored in one color, and that's for idea 1. Then for idea 2, I would change something else, do something different. Maybe add a blanket, like I said before, or popsicle sticks so it doesn't really go anywhere, it just kind of glides, and maybe that would probably slow it down a lot. So for each of those things that I change, I do my 3 trials, and then the average is what I record on the bar graph. Then after I've done all those ideas, I'll analyze the results. So which idea made the can travel the shortest distance? So which one had the smallest bar for the bar graph? Why do you think this was? Why was that idea such a good idea? What else could you do to make the can travel an even shorter distance? So what else could we do? And then can you explain your results using your knowledge of friction? So we learned a lot about friction. Can you use what you learned to tell what just happened, what just went down? Then you'll do this final reflection page, and that will be it for friction. So pretty fun. Let me know if you need help or anything, but I'm sure you guys are doing a great job. Yeah, that's our science experiment. I'll talk to you later.